percentage yet. I want to be able to talk. All right, so that should be it, right, Yuri?
Yeah, we'll see it now.
All right, here we go. Okay, I'm getting really bad reverb from somebody. All right, so yeah, good job on the test, people. We averaged an 88, which is about 2.5% better than last year. Like I said, I wanted a 90, but I also wanted to be 6 foot tall, and so I'm used to disappointment. All right, come on, that was funny.
Me too, Mr. Denton.
Who said that?
Sorry.
Was that Savage?
Yes.
Yeah, you wanted to be, but you are 6 feet tall.
I'm 5'9.5".
I'm 5'10". I'll switch with you, Dad.
There is no way you're 5'9.5", Savage.
Alright, you're right. I'm like 6'2".
Okay. Then. Alrighty. So you guys see my counter?
Yeah.
Okay. Alrighty. So it is 3:27 today. This is Chem 11:10, Chapter 12, Day 1. And I'm not sure if you're aware, but this is like the second to last test. Yeah, tell me that's not awesome. Which means for most of you, you're set because your grade's, fine. I do think, though, I have every student now above 65% test average. So that's a positive, right? Alrighty, so objective for today is going to be able to better understand organic compounds. Alright, now, what we're going to do is tentatively, I have this scheduled for 3 days. Okay? I do think, though, we might be able to go a fourth because obviously we won't be doing the lab. My only concern is students that choose to go 100% watching the videos, which is still an option. I'm just a little worried about them not being able to get their questions asked. So we're going to go for sure 3 days of teaching. Then we'll go for sure 1 dedicated review day. Then I'll probably do what I did the other day. I'm hoping it helps. Did that help at all to have that little hour-long review right before we took the test?
Yes.
Yeah.
So we'll probably do that again. So that would give us technically a 5th day on this unit, which I think might come in handy. There are a couple things that are going to challenge us. So, we'll just kind of see what happens. Alrighty?
So are we just never going to do the labs?
Well, who was that?
It's Tatum Butler.
Yeah, so Butler, right now, the direction I'm getting from the college is to just postpone them. I don't even know if I should say this, but I have a really bad feeling that we're not coming back.
Okay.
And so right now, I would say probably not. I would really like to do 5 because it's got chromatography in it, and I think it's a great visualization of what's going on. The only problem is that the labs really have nothing to do with the chapters. So from that standpoint, it's probably okay not to get them done because they don't benefit us at all. If we do come back in May and we're done, we'll probably go back and do them because Lab 5 has some fascinating components in it. And then actually the last lab, we get to extract DNA. And they're both really good application type things. So I'm hoping to get them in, but I don't know yet. Okay?
Okay.
Alrighty, now, couple of things we're going to start out with, and some things you must memorize. Okay, now I say must memorize let's be honest, most of you will put these on your 3x5. What you need to do is you need to know the first 10 anes. Okay, and what that means is you got to know methane, ethane, propane, butane. Wow. I got way ahead of myself there. Pentane, hexane, heptane, octane, nonane, and decane. Okay? You have to know those 10. Okay? And what these are the first 10 anes. Okay? It's like methane is CH4. Ethane is C2H6. Propane is C3. Anybody see a pattern happening yet? What would propane be? What?
They're just counting up.
Well, yeah, but how do I get my H here? It's C3H what?
8.
8? So how do I get there? If it's an ane, it is CX and it is going to be H what?
Plus 2.
X plus 2.
Well, if that was the case, wouldn't that be a 5?
X plus 4.
Anybody else?
2x plus 2.
It's 2x plus 2, right? So butane is going to be C4H10, right? And I got C5H12. That's supposed to be a subscript. So then I got C6H14, C7H16, C8H18, C9H20, and C10H22. Okay? Now, these are the most common ones we're going to use, simply because they can only get so complicated, right? Now, the first 4, methane, ethane, propane, and butane, obviously have kind of given names. Once I get above there, though, what do these look like? Anybody notice anything about these 6?
Like the pentagon, hexagon.
Exactly. They're based on what?
Numbers.
No, they're based on what? I think that was a Tolman, right?
Yeah, like shapes in the numbers.
Yeah, they're based on geometry, right? You know, a pentagon has 5 sides, so pentane is C5. A hexagon has 6 sides. Hex, hept. I'm assuming it's from maybe Latin or some old language, whatever's where they came from, but that's what we're going to do. Now, again, most of these you should just be able to remember. I, again, would not dedicate any of my 3x5 to these. I just wouldn't, simply because I don't think they're that necessary. But you will need to know them. Okay? Does that make sense? Now, from there, you need to know what the term acyclic and cyclic mean. Okay? Acyclic, this is when it is a straight chain. Okay? Whereas cyclic means it forms a what?
Ring.
Yeah, forms a ring. Now, not to be confused with a what?
Benzene ring?
Yeah, not to be confused with a benzene ring, but it does form a ring. So, for example, if I gave you this, okay, what would this one be?
Cyclic.
It is, you're right, but what would it be? Anybody know?
Hydrocarbon?
Hexane.
It'd be hexane.
Oh.
Who was that?
Trail.
Okay, so, Jace, how did you know it was hexane?
Because there's 6 carbons.
6 carbons, right? Nothing else there, that's got to be hexane. Now, this one, so I'm probably talking Miller or Mitchell or Staley here. Are either of those 3 on here besides Miller? Is Mitchell or Hannah on here? Negative. Anyway, they were the other two that had done all the learn smarts. Anybody know what they would call this?
It's the hexane again, isn't it? There's something 6.
You're right, but there's something in front of it.
I remember it off the learn smart.
I know it was on there. This is cyclohexane. Now, it's important that you understand that there's a distinct difference here. For one, hexane is C6H14. Cyclohexane, though, is what? Anybody know? Nobody?
C6H12?
Yeah. Why?
Because they all only need 2.
Exactly, because they've basically taken the 2 and H's and they bonded those carbons together. So they've removed 2 extra H's. So anytime it's cyclo, it's just CxH2x now. Okay? And I can do this with any of them except methyl and ethyl because I can't form a cyclical structure. But I can with propane and then obviously anything above that. Okay? So, acyclic, cyclic, this is what acyclic looks like, this is what cyclic looks like. Okay? The formulas change. Okay? Now, well, let's talk about this. Can I turn this sheet? Yeah? Alrighty. Now, there is 3 or 4 questions on the test on this one topic, and it's what's called a constitutional isomer. A constitutional isomer. Now, pay attention to this. They differ in the way the atoms are connected. Now, what this means is they're going to give you, they're going to ask you this question one of a couple of ways. Okay? And it might look something like this. So let's say I do this, and I do this. Okay? And it's going to be something like, are these constitutional isomers? Okay? Now, the way I do this is not technically the exact same way that the book does it, but as I went through the test, these work. What I'm going to do is I'm simply going to go out and write the formula for each one of these, putting them all together. Okay? Well, this one would be what? Like that was a legitimate question. Anybody know what the formula for that would be?
C6H12.
C6H12. Is she right?
Yeah.
Yeah? What would the formula for this be?
It's the same thing.
Yeah, it would.
H11.
H11?
Yeah. No, it's H12.
H12.
Should we look at it?
It's really small because they're 3.
Look, so,
Oh, yeah, H12.
Wow.
right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right?
Yes.
So do these have the same formula?
Yes.
Yeah. So are they constitutional isomers then? Yes.
Yes.
Because all that means is they have the same formula, but they're bonded together differently. And you notice this really easily if you were able to name them. Now, granted, you don't know this yet, but there's like, I don't know, 8 questions on the test on naming, and we're going to hopefully get there before the day's over. This, though, we already know, this is cyclohexane, right? This is what is known as methyl pentane. Okay? Obviously they have different names, which means they must be different compounds, right? But they have the exact same formula, which makes them constitutional isomers of each other. Does that make sense? Yes or no?
Yes.
Okay, so now let's say I did this. Let's say I gave you those two. I said, are they constitutional isomers of each other?
No.
No? Yeah?
Yes.
Yes or no?
Yes.
Yes.
Yes? So,
Just like this H's.
say that again?
Just like this amount of H's, does that not matter?
No, gotta be the exact same.
It's in different order.
I got 1, 2, 3 C, so I got C3, right? And I got 3, 4, 5, 6, 7, H8, right? And then an O, correct? Or no? Is that right or not?
That's right. Yeah.
Okay, and then over here I got 1, 2, I got C3, right? I got H3, 4, 5, and 3 is H8, and an O. Do they have... What's the matter?
Oh, I just miscounted.
But does that make sense?
Yeah.
So yes, they are constitutional isomers, and I know they're bonded together differently though because that O's here, and that O's in a different place, right? I could draw that out and show you, but I really don't think that's necessary. Does that make sense?
Yeah.
Alrighty, now, you know what? Let's start naming these. Now, while I'm thinking about this, there is something we need to understand, and that is that we are gonna have spring break. Okay? So I guess the rumor, has anybody heard the rumor that we're gonna go to school through spring break?
That's a rumor?
Yeah.
Okay.
Yeah, I was actually in a meeting with the principal yesterday, and apparently a bunch of parents had called the school because they had heard because of the way we're doing this, we were just going to go to school from now until the end of April when we come back. You know, tentatively, that's the way it's scheduled. And Mrs. Poe is very adamant that no, there will be no homework next week. There will be no schoolwork next week. Unless, you know, your teacher's giving you something to work on. But, like, there's no teaching going on. Nobody had heard that?
No.
Oh, okay. Well, then don't worry about it. So, yes, like, I'm gonna teach today, and then I won't be teaching again until the 6th. And we're going to pick right back up where we're at. Does that make sense?
Yeah.
All right. So, now, what we're going to do is we're going to start in on probably the hardest topic in this chapter. Okay? And what I'm thinking is if I at least introduce it today, when we do come back from spring break, we'll have at least seen it, and it won't be completely foreign to us. Now, naming alkanes. Now, there's two things you've got to look at. The first thing is you've got to find what is known as the backbone of whatever it is. Now, this is what they're going to do. Okay, so let's say this is my hydrocarbon. Okay? Now, there are a whole bunch of rules that we're going to go over. And what's going to happen is that we are going to kind of work our way through these rules a little bit at a time, okay? And I'm going to try to teach you a system that allows you to name any hydrocarbon that they show you, okay? Now, first thing I want to do is I want to find the longest consecutive backbone. And what that means is the longest chain of carbons bonded together, okay? Who wants to tell me how many are in the backbone of this? 8?
7.
I got 11.
You got 11?
I got 11 too.
I get 7.
Okay, well I get 8. Let me show you why. So you got 1, 2, 3, 4, 5, 6, 7, 8. Oh. Is that the longest consecutive chain?
Oh, okay.
Doesn't matter which direction it's going, it simply matters because it doesn't matter if I go that way or this way, I've got to go with whatever is the longest. Okay? Now, what if I would have done this? Is there a difference there?
No.
There isn't, but you will learn that there is. Okay? Now, what happens is this, is whenever you name a hydrocarbon, okay, you're going to use numbers and you're going to use names. And the sum of the numbers you use in there needs to be as low as possible. Okay? So like right here, excuse me, if that's my 1 and that's my 2, this branch right here would be what is known as a methyl branch. Now typically, that's 1 carbon, right? 1 carbon's name was what? What was the carbon if I only had 1 carbon in it? What?
Methane.
Methane, right? Well, why do you think I wrote methyl?
Carbon.
Okay, but why the O instead of methane?
So there's 4 hydrogen.
Okay, close. The fact that it's methyl now, the YL, means it is a branch coming off of my main chain. Okay? This one, what would this one be? Coming off of this 5 carbon.
Would it be ethyl?
It would be ethyl now. It would have been an ethane, but because it's branched off of my hydrocarbon, I name it an ethyl group. Okay? Now, I'm gonna write down the name for this and then I'm gonna talk you through it. Okay? So, okay? Now, this would be 2-methyl-5-ethyl octane. Now, the other alternative would have been, whoa, check that. Check, I screwed that up. That is wrong. Whew. Yeah, we're just going to erase that whole thing. Anybody notice what I did different between those two?
Switch the ethanol and the methyl.
Who was that?
Dual.
Dual. Any ideas why I did that?
Does the higher number have to come first?
Nope.
You work from right to left.
Say that again?
You work from right to left, don't you?
No. Anybody else? They're both good. They were both good ideas.
He works backwards. it because ethyl has 2 branches and methyl has 1?
Nope.
The alphabetical.
I heard it. Winner. Who is that? Okay, what do they have to be?
In alphabetical.
Alphabetical order. Okay? Now, and if you notice, it's 5-ethyl-2-methyl octane. The alternative with the red letters would have been this. Would have been 4-ethyl-7-methyl octane. Now, the reason this doesn't work is because the sum of those numbers is 11. The sum of those numbers is 7. I always assign it with the lowest sum possible. Does that make sense? So, when you start to number a chain, when you start to number a backbone, you always want to start where you're going to branch the earliest. So, here I was going to branch at carbon 2. Here I wasn't going to branch until I hit carbon 4. If I do that, I'm 99% of the time going to end up with the lowest sum. Does that make sense?
Yeah.
Yeah.
Let's do a few more, okay? Now, let's say I did this. Okay, so there we go. Now, do I want to number this one right to left or left to right?
Right to left.
Right to left, so I want to start over here?
Yeah.
Why?
Because you branched earlier.
So I'm going to branch off my third, whereas if I start over here, I'm going to branch off my fourth, right? So I'm going to go 1, 2, 3, 4, 5, 6, 7. So no matter what, when I'm done, this is going to be a what? What kind of compound will this be?
A heptane?
It's going to be a heptane. Heptane. I like to start with that because I know what I got to be when I'm done. Right? Now, off my fourth carbon is a what?
Ethyl.
That's an ethyl. Off my 3 carbon, I actually have what?
Is it 2-methyl?
Now, I got a methyl there, and I got a methyl there, which gives me a what? Anybody know?
Dimethyl.
Gives you what is known as a di. No dash there. Just dimethyl. Dimethyl. Now, they are very, very specific with how you write these. And when I do it, you will actually hear me say it to try to reinforce that. So, for example, this is what this is going to be. It will be 4-ethyl dash 3,3 dash dimethyl. Damn it. Sorry, I'm not moving enough. There's not a bunch of kids in here moving around to keep my lights on. Okay? So 4-ethyl dash 3,3 dash dimethyl heptane. Okay, now, what do you notice there? Okay, so commas only go between numbers. So between any numbers that are in the same thing, I have to put a comma. Between any number and any word, I have to put a dash. Notice, right here I've got dimethyl. Okay? Well, doesn't dimethyl start with a D? Yeah.
You go off the base word.
I go off the base word. Now, understand. Was that you, Brecken?
Yeah.
Now, understand that there are a couple of exceptions to that rule that I'm not going to talk about today. But if I use one of the Latin prefixes, mono, di, tri, tetra, things like that, then I do not count them as being that. I go off of, you're right, the base word. Okay? There are a couple of compounds we will learn in this chapter where you do count the first letter. Like one of them is isopropyl. Isopropyl is propane, but it's branched differently. Okay? And so in that situation it does count, but I'm going to talk about that later. I just want to get through several of these, make sure we can understand what's going on. Okay? Let's do another one. Let's do this. Let's do that. Now, when I'm done, what is this going to be? Anybody know?
Octane.
Nope. Anybody else want to take a guess? What if I write this? Cyclo rules.
Oh.
Anybody know what that means? Nobody?
Is it cyclooctane?
No, it's going to be... Okay, I heard it. I heard it. Cyclo what?
Butane?
No. How many carbons are there? Cyclopentane. It's cyclopentane because my cyclical structure has 5 carbons in it. And anytime I have a cyclical structure, it takes precedence. Now, here is where this cyclo rules, meaning it's what I'm going to look at first. Does that make sense? Now, here's the question. I could go 1, 2, 3, 4, 5, or I could go 1, 2, 3, 4, 5. Now, in doing that, what do you notice about my sum? It's going to be the same, no matter what. So, the next rule is if the sum is the same, anybody want to take a stab at what you would do next?
You go number order.
What do you mean?
Like, if you can change between if it's the 1 and the 2 that comes first, you make sure the 1 that comes first, because it doesn't really matter.
Who's singing?
Hayden.
Hayden.
I don't think he knows he's not muted.
Hey, whoever's singing, mute your mic.
Do so.
Oh well. Okay, now, so what happens is, what is this branch? What's this branch going to be?
Ethyl.
It's an ethyl. What is this branch going to be? A methyl, right? So what you do is, because the sum is going to be the same, I then go in alphabetical order. Okay? So, I know my ethyl is going to come first. Because the sum doesn't matter, it's the one I'm going to assign the 1 to. So this would be 1 dash ethyl dash 2 dash methyl cyclopentane. And we would go with the red numbers and not the blue numbers. Does that make any sense?
Yeah. Why would you go with the red?
Say that again?
Why would you go with the red numbers?
Because E comes before M, right? So I'm going to write the ethyl first. If I have a choice, I want to assign the lowest number to the first word.
Oh, okay.
If everything else is equal, I go alphabetical and I just assign that number with that letter. Does that make sense, Allison? I believe that was you. Yeah?
Where do you know, where to start for, number 1, though? You know what I mean?
Okay, that's a great question. I'm always going to start where I'm going to branch the first, right? Well, if I have a choice, I'm going to start where there is a branch, and then I'm going to go the direction that gets me to the next branch first. Does that make sense? So let's say I did this. Here's a good question, Yuri. Is that Yuri?
Yeah.
Okay, so here's a really good example of that. Let's say I did this. Okay, so here's a good one. So now, no matter what, I'm going to either start here, okay, right? Or I'm going to start, I could start there, right? What is wrong with the first set of numbers I wrote down? Let's just get that out of the way right now.
You didn't take the shortest route.
Exactly. And who was that?
Mumford?
Okay, Mumford, why will I always want to take the shortest route?
So you don't have to write all of the numbers in between?
No.
Put a sum to the lowest sum.
I heard it. What was it?
Smaller sum.
Smaller sum. So yeah, I will never want to go that way. So let me just do this, because if not, we're going to get way too many numbers here. Okay, so I know it's going to be 1, 2, 3, 4, 5, 6. Now, that's one option. What else could I do, though?
You could start at the methyl.
Yeah, I could start here and go 1, 2, 3, 4, 5, 6, right? Now, let me show you something that can save your time. Okay? What I would do is before I even number them, I'm going to go and name these. Because again, I'm a 1 and a 3 and a 1 and a 3, right? Correct?
Yes.
So in that sense, it's not going to matter, right? So I'm going to go and I'm going to name these so that then I know whichever one comes alphabetically first has to be my first one. Do you see what I'm saying?
Yeah.
So this is a methyl. What's this?
Butyl.
Butyl, exactly. Good job. That's a butyl, right? So, because B comes before M, I know I'm going to go with the blue ones, right?
Yeah.
And it's going to be 1 dash butyl dash what?
3.
3 dash
Methyl.
And then all one word. This last part's all one word. It's going to be methyl, and then it's going to be
Cyclohexane.
Cyclohexane.
Why is that methyl?
It's an ethyl.
Yeah.
That's an ethyl.
Man, who's at the door?
If only that actually works.
Now, I said that in my last class, and then all of a sudden I said, oh, hey, there goes somebody running for the front door. Nobody gets that joke. Nobody gets that joke.
This was a great thing.
That had to be. Now, leave it to Hudman to only contribute when she's going to slam on me. I find that quite ironic, Hudman.
Holly just turns her mic on so she can laugh.
Exactly, jerk.
Your jokes suck.
Now, luckily,
I have a question.
yo.
So why do you not do the continuous, like the longest continuous carbon chain?
Okay.
Or is it because it has like the ring?
Because anytime there's a cycle in it, it rules. Meaning that's what's going to determine what it is. And what it boils down to, is that you, Muller?
Yeah, it is.
Okay, what it boils down to is that cyclical structures have very different properties than straight chain structures. And the cyclical structure, those properties take precedence, so that's how we're going to name it.
Okay.
Okay? So anytime you have a cyclical structure, that is going to be what determines what it is at the end. everything else will be a branch from that. Does that make sense?
Yeah.
Okay.
Yeah, I was wondering, I was like, shouldn't it be 11, but we got it.
Yeah. Now, the other rule, the one you're doing, applies if it is a straight chain or a backbone chain. Does that make sense? So let's go and look at another one. Let's say I did this. Now, somebody tell me when we're done what this is going to be.
Would it be a decade?
Would it be a decade? I don't know, you said that as a question.
Yes, I did. It's a decade.
It's a decade? Is that Brecken?
Yes.
Is he right?
Yes.
Yes.
He is. Now, which way do I want to number this? Left to right or right to left?
Right to left.
Right to left, I'm going to go.
It doesn't matter.
Okay, why doesn't it matter?
Because it branches the same number.
Exactly, they're both fours, right? So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, because these are both what?
Methyl.
They're both methyls, right? Both methyls. I'm going to have a what in there?
Dimethyl.
I'm going to have a dimethyl, right? So, how am I going to start numbering this?
4,7 dash dimethyl.
4,7 dash what?
Dimethyl.
Dimethyl
Decane.
decane. Just like that. There's a C in there. 4,7 dash dimethyl decane. Is that making any sense?
Yes.
Yeah? Questions?
I have another question. On the Learn Smart, it talked about more about, what was the word? The names of the things last time, like the esters, but I can't think of the word for them right now. The ones that start with A, like alkaline and stuff. So on the test, do we have to name those as well?
You mean like the aldehydes and things like that?
Yeah.
Yeah, there are a few of them. What I was going to say, not today but next time, is that'll be a situation where they will ask they're going to ask a more specific question, okay? They're a different kind of question than this. Does that make sense?
Yeah.
And what?
I was just wondering, because where they were on the Learn Smart, I just wondered if it was like a review thing.
It is a little bit. Actually, both these next two, like 11, 12, and 13, have a ton of stuff in common, and so there will be some overlap there. So yeah, I would definitely say there's going to be a few, but I can only think of one, maybe two questions off the test that are going to reference like the esters and the aldehydes and the carboxylic acid things. But once I teach like day 2 or day 3, one of those two, that'll make more sense. Because we do get into like some benzene ring derivatives, like they're called like toluene and things like that. But that's not for today. But we will get there. So I guess, yeah, your answer is yes. There is a little bit, but not a ton.
Okay.
Okay? Alrighty, now, let's say I did this. Alrighty, now, how is this one different than anything we've done? Yeah, it's now an alkane because it has a what? Double bond that has no what though?
Branches?
No branches, so we're going to start out simple. Now, same idea here. If I'm going to number this, am I going to number it left to right or right to left?
Doesn't matter.
It does matter.
Right to left,
Why right to left?
because we still have to put in the alkene.
I do. I've got to signify where that ene is at, and I want it to be just like the other rule, the smallest number possible. Okay? So this would literally be, what's this, hexene? It would be 2-hexane. And what that 2 does is it tells me where that double bond is at. And that's it. 2-hexane. That's all you do. Does that make sense? Hello?
Yeah.
Yeah? What if I did this? Let's say I did that. What's that going to be?
Alkyne.
It's an alkyne, right? Because now I got a triple bond. How am I going to number that? Left to right or right to left?
Left to right.
Yeah.
Correct.
1, 2, 3, 4, 5. Because if I would have went the other way, it would have been a 3. Going this way, it is a 2. I still want it to be the smallest number, right? So this would be 2 what?
Okay.
2 pentyne. 2 pentyne, just like that. And that 2 signifies the first carbon I come to that contains the triple bond. Okay? Now, the same rules apply. What if I did this? Now, this one always gets some people. Let's say I did that. Now, how am I going to number this? Left to right or right to left?
Left to right.
So I go 1, 2, 3, 4, 5, 6, 7. So no matter what, when I'm done, this is going to be a what?
Hexane?
Close. It is a hept, but I'm gonna teach you something here. Now, okay, it's a di, and this is where this kind of gets a little wonky. This is 2,4 dash heptadiene. Now,
Yeah.
traditionally, people want to write it like this, 2,4 dash diheptene. Who can tell me what the difference is in those two words?
The second one is saying that there's 2 heptenes.
Exactly. And that's exactly it. This is saying I've got 2 heptenes. This is simply telling me I've got 2, whatever makes it an ene, which means I've got 2 double bonds. Does that make sense? So that's where the di goes at the end right before what makes it what it is. So it'd be 2,4, meaning my double bonds start at the second carbon and at the fourth carbon, right? I've got a comma because I put a comma between every number, and I put a dash between a number and a word. 2,4 dash heptadiene, a 7-carbon chain with 2 double bonds in it. You see how you can kind of decipher that?
Yeah.
Yeah? Anybody else agree with that or no?
Yeah.
Yes? Okay. Alrighty, so we are at 50 minutes. You know what? We're going to stop there. I think that's giving you enough to chew on for right now. So remember, we're going to go for the month of April. Once we get started, we're going to go Mondays, Wednesdays, and Fridays at 9 a.m. Now, I'm going to be honest with you. This is eventually going to catch on. Do you know what I mean when I say that? Nobody knows what I mean when I say that?
Like other classes are gonna start to do the same thing?
Yeah, so most teachers just thought, oh, I'm just going to have them do some busy work for 2 weeks, right? Well, we couldn't afford to do that, right? So we just kept going. Well, Mrs. Perry had me craft an email to the faculty to kind of explain how I do things, because I think it works really well. I mean, what do you guys think?
It's amazing.
Yeah.
Fabulous.
So she had me craft an email that she's going to send out to all the teachers. So teachers are going to start to clamor for your time. You guys need to make sure you understand that you need to put the classes that matter first. If you got a class that's more important than mine, and they're going at 9 o'clock, go to it. Because I still record mine, and you can still watch this online. You know what I mean? But if you don't, there's nothing better than being here. Because really, is what we're doing right now any different than what we did in class? No. So I think this...
You can't play the Raising Handy game.
Actually, I played the Raising Handy game today.
You did?
Yeah, in my other class. What I did is I had them count. So once they got the answer, they would say 1, and then the next kid, when I could just... It actually worked great. I just didn't think we were far enough along today to play that. But we will definitely... What?
I said, that's very clever.
Yeah. I'm on top of my game. You know, I try to be. So, we're going to go Monday, Wednesdays, and Fridays at 9. I think that's the best way to do it. That way we have a set calendar, and it just is going to go, because my math class, I'm going to go Monday, Wednesdays, and Fridays at 8. And I can usually get through them in about 40 minutes, which gives me enough time to go over, get the email sent out, and get this class going. Alrighty? Again, if you have any questions, don't hesitate to email me. Some of you have my cell phone. I mean, if it's dire, you can call me. So yeah. Any questions? Nobody? Enjoy your break, and I will see you back on April 6th, right? April 6th at 9 a.m., correct? Isn't that the date?
Yeah.
Yep.
Okay, see you guys. Yep. See ya. Did anybody happen to notice the biggest number we got to?
Is that
76-ish.
76-ish. Wow, that's awesome. Thanks, Cameron. Okay, see you guys.